texture in question was this. So this is a sprite sheet that has explosions, one frame of animation per 100 pixel section. And the goal was to, from this image, pick a rectangle and move that rectangle through the texture to simulate an animation. So let's just go through and show how to actually set it up so that we can draw this explosion. So everything that is a file on disk needs to be loaded into SFML via this texture variable type, so SF texture. Typically I will name my variables to represent the type of object it represents, so explosion texture. You will load it from a file by specifying the path to the file, which is it's in content. And you know the path is there because when you're working in Visual Studio, when you're running through Visual Studio, everything is run relative to this directory where the VCX project file lives. So content is actually where this image lives, so content explosion.png. And the first thing I just want to do is create a sprite. And I'm going to call explosion sprite. And explosion sprite is going to get a texture like this. So it's just a texture and a sprite. And then we just need to draw that. And I'm not going to draw the green circle anymore. I'm just going to draw the explosion sprite, like so. And this will draw the full image, or try to fit the full image on screen. And notice that there's more that's going down that you can't see. Okay. So the key is that you want to pick out a square that you want to show at any one time. You don't want to show the entire rectangle. Let me do this. Adjust this theme here as well. Okay. So this explosion sprite has a function that you can call on it that is setTextureRectangle. And setTextureRectangle takes a rectangle that specifies what size and where this rectangle actually lives. So I'm going to start with 0, 0, and I believe these were 100 pixels wide by 100 pixels tall. And the goal is that I want to just draw the first explosion here, the first sprite of the explosion. And if I wanted to draw, let's say, this one here, that is one column over and 2 rows down. So I can specify that by doing 1 column over times 100 pixels and 2 rows down times 100 pixels. And this number here indicates which row and which column I want to show for that explosion. So this will pull out just that. Oops. This will pull out just this image right here. So to animate this, to start, I'm going to just have it animate 1 row at a time just to see that it actually goes through the row. And to do this properly, you need to keep track of which row you're on. And let's just start with column this time. I want to animate from left side all the way to right side. This right here represents the column that I want to pick from, right? So if I just change this to be a column here, and if I, inside the loop, if I just add 1 to the column through this loop, and also every time through the loop I recalculate what texture rectangle I want to set. So I move that line of code down into the loop. Now my explosion will rapidly fire quickly from left to right, very quickly at the beginning, and then keep going past off the right end of the texture. As you might have realized, that this column here will not stop at the number of columns I have inside my texture. It actually just keeps going. So you need a way to be able to stop this column when it hits the end and then restart it at the beginning. So if you, inside this loop, if the column is greater than or equal to 9, I believe, 2, 3, 4, 5, 6, 7, 8, 9, means that if you're at the 9th column or higher, that means that you actually need to restart your animation all the way from the beginning again, which will mean that now when your explosion hits the end, it'll go back to the beginning of the frame. And this is great because now we can just let it sit here and it'll loop the animation. We do want it to go through each of the rows though as well. Like right now it's just going through the second, all the columns. We do want to actually go through and move rows as we're going to the end. Kind of like a typewriter that goes from left to right and prints out the text. We want this thing to go left to right and top to bottom. So that's also pretty easy. You just need a way to be able to specify which row you're on, just like the column. And instead of specifying a row right here, I could use the row variable. And every time I go to a new column, I could also increase the row. And then what I can do is, if the row is greater than or equal to, I don't know how many there were. I think there were also 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If there's also greater than or equal to 9, I have to restart the row as well because I want the row to go back to the top when I'm done. So it's going to go left to right, top to bottom, all the way to the end, and it's going to restart all the way at the top here, which is why I have this condition right here. So if the current row that I'm on is greater than or equal to 9, then I'm going to restart the animation here. So now you have it so that the explosion will probably go through all the frames of animation. And so the trickiest part of homework wasn't really this. It was how do you figure out how to stop the animation from going so fast? Well, why is the animation going so fast to begin with? What is making this thing flash like crazy right now? Well, how many times is this thing switching frames of animation? Like how fast is it switching? Yeah, as fast as a computer can. How many FPS do you think I'm getting in my game right now? Yeah, probably like something ridiculous. Let's see. I don't think there's a way for me to tell. I guarantee you it's like 300 or 400 frames per second. So what that means is that you're animating this entire thing like 5 or 6 times per second, the entire thing. So you need a way to say, hey, don't just blindly switch your animation all the time. What you actually want to say is, hey, I don't want to always just move to the next frame right away. So there are 2 ways that you can do this, and really the simplest way is to put a condition around this so that it doesn't always animate every single time through this loop. Because remember, this loop is happening as fast as it can. It's going through this loop as quickly as possible. So one way you can kind of throttle that is you can have something like a variable that controls how oftentimes it goes through and adds that frame. What we can do here, I can create a variable, let's say called counter. I'm going to start it at 0. And if I have the counter, if I just add 1 to the counter every time through the loop, this thing will just count up indefinitely. If I make my counter something that I use in a condition, like if the counter is greater than 100, for instance, and I wrap all of this logic in, like so, and then reset the counter back to 0, this logic right here will mean that I have to go through this loop 100 times before I even do this once. Which means now this loop will basically stop updating the animation every single time. It only updates it a little bit. It only updates it once every 100 times through the loop. Which means now, even though I have my animation, you can see it's actually doing that only 100 times every time through the loop. I basically effectively cut the number of times it animates by 100. And this number here is something that you can tweak. If you decrease this number, it'll animate slightly faster because it can get to that number faster as well. And so you can animate this thing like that. All right. So that's one way you can do this. The only downside to this method is that depending on the computer that you're running this on, sometimes some computers will count up to this number faster than others. If you ran this on a computer that's like 10 years old, it wouldn't be able to go through this loop as fast as a computer that's released like today, right? The computers that are today are much faster. They're able to do much more work. They're able to run this loop much more quickly, which means that the number of frames per second on a new computer is faster, so that animation will actually move faster too. And there is a way to stop that from happening. So, and we're going to get into more detail about this method in about 2 weeks when we do ball movement and like velocity in games for Pong. But for now, I'm going to show you another method that you can use to do this. There is something called a clock that you can use in the SFML library, in the SF namespace. I'm just going to call this clock. And clock is interesting because it keeps track of time as it passes. So it keeps track of not just, how many times through the loop or anything. It actually keeps track of physical, real-world time. And you can use this to basically slow down your animation and be very specific about how often you animate. So clock also has an associated variable type called time. I'm going to call this one delta time. And if you call this function restart on a clock, restart will reset the clock that it's been counting so far and then return you how much time has passed since the last time you called restart. Which means now I have this delta time variable. And delta time is interesting. It's just time. This is literally just how much time has passed since the last time I've gone through this loop. And what's nice is that you can use this to figure out how much time has passed before you want to animate it again. So instead of using this as an integer counter, I'm going to create a float counter this time because I'm going to represent this with floating point numbers. And let's just comment this out for now. I'm just going to show you guys what this delta time is actually doing. So I'm just going to do cout delta time is delta time. And delta time by itself is both seconds and milliseconds. It's stored internally as microseconds, I think. But there's these three functions you can call. And the one that you care about is the one called as seconds, which means just get me the time in seconds instead of in milliseconds. So if I run this, and I need to include my, if I just run this and you guys look at the console output, I'm just going to make this thing bigger. So this right here is how many seconds have passed between each loop that I have. So if I want to figure out how many frames per second I'm getting right now, I can take one of these numbers, which is like 0.0022, 1 divided by 0.00224. I'm getting 446 frames per second right now in my game. Sometimes I'm getting even faster, like 0.01 divided by 0.0015. I'm going all the way up to 666 frames per second in my game. So my game is running very fast, which means that this time, the seconds that have been passing, represents how many frames, how long it took to do a single individual frame. So now that I know that information, now that I know that this is representing how much time has passed between frames, I can add that number to my counter. And instead of printing out delta time, why don't I just print out time elapsed? That's going to be this. I'm actually going to rename this thing to time elapsed. I'm going to start at 0, and I'm just going to print that out here. And this right here is just a float. And now when I print this out, you're going to see that this actually represents the time since my game started running, and it's going to start counting up from 0. And you can notice that it's actually going up once per second, right? So this right here, this variable that I have, time elapsed, is representing the seconds that I've passed since I started the game. Knowing that information, I can use that here in my if statement. So if the time elapsed is greater than, let's say, how many frames of animation do I want? This maybe, we can do 30 frames per second. That's the typical, so 0.033. So 1 divided by 30. This is how many frames per second I want my animation to run, is 1 over 30, which is the same as 0.0333. Reset this back to 0, and then run my animation. It's the same idea as the counter, except I'm doing it based on time. And you can see here, it's a 30 frame per second animation. And if I want to make this thing run faster, I can change this to be a 60 frame per second animation. Uh, 60 FPS. And you can just double that to, again, maybe 120 frames per second for animation. This lets you control exactly how many frames per second you want your animation to take. So this is going to be 120 frame per second animation. Okay.
I have a question, Keith.
Yeah. What's up, Dom?
I did it, mine's a little different. I did a wild true loop at the very end behind the window of the store, and I used sleep.
Okay. Sleep is okay for this example. You almost never really want to do a sleep in the middle of a game, because what that means is that your entire game will not be able to do anything while that's happening. So when you sleep, it means you can't get input. It means you can't render anything else. You can't play any sounds. Your game is basically stuck there doing nothing else. So sleep is like something you rarely use. Like typically you only use that if you have something that is waiting on something else to finish, if you have a separate thread that's waiting on something to finish. In our case here, we don't really want to use a sleep because we want this thing to still loop as fast as possible. When you sleep, you effectively lower your frames per second for your game. If your game was running at like 100 or 600 FPS and you put a sleep in there, now your game is forced to run at no higher than whatever you set it to sleep at, which might be, I don't know, 30 frames per second or 60. You typically want your game to run as fast as possible. Okay, so that's how it is. Yeah.
So, if you do you have to use the clock and the time, or would there be another way to use it? Like do it without that?
Without this?
Yeah.
Well, I mean, you could use it using the counter that I just showed earlier. That's another way.
If could you by chance use a float and use it similar to the way you use counter? Would that work as well?
Oh, you mean like do like this, plus equal 0.1, something like that? And instead of doing this right here, and instead of doing this right here, like delete all these? In theory, this works. The problem, again, is that this amount that you're adding is based on how many times through this loop. Like, this loop runs at 600 FPS on my machine, but if I ran it on like someone's laptop, maybe it doesn't run at, maybe it doesn't run at 600 FPS. In fact, I think if I do something that makes it, see how it slows down and speeds up too periodically when I'm not like looking at it? So that's actually indicative of the fact that my game is not consistently running at the same frame rate. It goes up and down between like 300 to 600 FPS. And the reason why this doesn't really work well is because this number here is the same no matter what computer you're running on. The reason why this works so well is that this number right here changes based on what computer you're running on. This number right here will be much bigger on slower computers, which means you'll go through the animations the same rate as a faster computer. Like I could run this game on any machine and that explosion animation will look exactly the same. If I used just the explosion animation will look exactly this way. If I use this method here to just like add 0.1 like this, or 0.01 to this like this explosion will look very different on every machine that plays it. Every machine that plays it will animate it slower or faster, and I can't get consistent results. Yeah.
Is this why some older games run like really fast?
Yes, that's exactly right. Because they had an assumption that it took X number of seconds to get from one frame to another, which is it's called throttling. So when you want to have something run consistently, you have to take into account how much time it takes to do each frame. So there are other ways. There are other ways you can do kind of what Vince is talking about. This method up here is a dynamic update, which means that the time between frames, this number changes. Overwatch uses what's called a fixed update system, which means that we force every single frame, every single time through this loop, we force it to be a specific duration. In fact, for us, we update at 60 hertz, which means we have 0.01666 seconds, or 16 milliseconds per frame. It's a very interesting idea, and I'll talk about it more later about what those two update systems are, but in Unity, if you're ever using Unity, you'll see two different methods that you can implement for updates. One is a traditional update like this. It's just called update. And another update is called a fixed update, which means that this time, in a fixed update system, Vince, you can actually do this. In a fixed update system, you can actually just do this every frame, and it'll look exactly the same no matter what machine you're running on. And the way that works is interesting, but I don't think it's really relevant right now until we get to the ball movement stuff. Okay. But so for now, what we're typically going to do is we're not going to use a fixed update system. We're just going to use this clock because it works pretty much almost the same as what the fixed update will do, except it's a little bit more straightforward to use.
So are there benefits to both methods, or is this a better method to use?
Yeah, I would say that fixed updates give a more consistent experience. There are benefits and cons. Like this is typically a more straightforward, easier way. It's almost the same. Fixed updates are very important for games that need physics physics simulations in them. So if you want to have physics have a consistent experience every time, or you're making a game that's called deterministic, which means that you're making a game that has to be the same exact way that you play it every time. Like if you have like a replay, or you have something like Angry Birds, where you have a physics-based game, you need something to be consistent every time, which means you need something like a fixed update system that this time here doesn't change based on a computer that runs it. Because the more that this thing changes, you get slightly different behavior between machines. Even though it looks the same, when you're dealing with physics, this thing being slightly different can actually be really difficult to deal with. All right. So this right here, this time-lapse thing, is what we're going to be using as well today for animating Link. So as you guys, now that you see how to change how often to animate it, you can use either method. It's fine for this week. Again, the simplest method is just to not use a clock and not use delta time, but just to use a counter. But this will also work for the explosion.
Are you going to put the CPP in the...
Yes. Yes, I can put this up there as long as John doesn't steal it. John, you have homework. You're going to hand this in, right? You're going to hand in homework? All right. I'll put this up on Zool, but I'll trust that people don't use it to do their homework. This is why I collect homework at the beginning, so that I can go over this and give you guys the stuff.
Accountability, John. Accountability.
Okay, so it's up on Zool. It's just called engine.cpp. Okay. So what we'll do here now is I want to go over the lab, and I have a little bit of a lecture as well, just a tiny one. So there are two things we're going to go over today. Okay, so I have two labs, one dealing with keyboard, one dealing with mouse. And I want to talk a little bit about how keyboard and mouse events are handled in SFML. So let's just exclude this guy. All right, does everyone have the engine, the project up and running? You should have something that looks like a green circle on your screen. Okay. So everyone should look like...
Huh?
You should have a green circle on your screen. Just make sure that that looks the same to you.
What does it mean when the, like, not this one, but when I try to look at some of my other files, it, sometimes it can't find this STDFX because I screwed something up?
Oh, I see. It depends. That is because depending on if you didn't make an empty project at home, you made one of the, like, if you made a project that
used the engine,
you use
and it
the
saves
console
over.
application,
Yeah.
there's an option when you're making a project that is, hey, use precompiled headers. So here, if you're making like a Win32 project or Win32 console application, when you do this, it'll typically ask you if you want to use this right here. That's why. It's because if you have this checked, you need to include...
I didn't start a new one. I was just using the same one that you gave us.
Oh, I see. In that
And it,
case
like,
here,
kept eating itself?
there's a header probably that is included at the top called like STDAFX,
Yes.
which you can just remove in that case.
Oh.
It's like this guy here. Yeah, if you have that, if it doesn't work at home, just delete this one here.
Oh, okay.
So I'll give you that. Okay, so for today, there's going to be I want to talk about keyboard first and how to work with mouse afterwards. So as I mentioned, keyboards are really important to games. You know, whether you're playing a first-person shooter or a MOBA or anything that requires you to like interact with the game that has a keyboard, you have to know how to read what the player is pushing on the keyboard. And this also matters for the gamepad as well. I want to talk about, there's actually like, it's not just a matter of detecting like what key they pressed, but also how they pressed it. That's really important. there are 3 distinct ways you can press a keyboard, right? 3 different things that happen when you press a keyboard key. You get a press that you actually first pushed like Q for your ultimate in Overwatch, or you are holding Q, means that you pressed it and you haven't let go yet, but you're still holding on to it. And then you let go of Q, which means that you pressed it, held it for a little bit, and then let go of it. And those 3 things are distinct, different. They each do different things in games. Like, for instance, movement, like when you're moving a character around with WASD, that's typically resolving through if you hold down a key on the keyboard, right? Like you hold down W and you move forward. You don't tap W repeatedly to move forward typically, you hold it down, right? Activating abilities in Overwatch, though, that typically is done on a press. So you press a button and that activates that ability. Sometimes, though, you do things on release as well. Like in Overwatch, Hanzo has a bow and arrow. He shoots his arrow when you release the mouse button, or if you are like gliding as Lucio, or like if you're gliding as Hanzo or climbing up a wall, when you let go of the space bar, it takes you off the wall. So there are things that matter for when you want to release a key. It's all 3 of those things are important, though, and determining which one you need to use for which part of your game is important for you to decide how you want the game to feel. Like if you want movement, typically you do that stuff by detecting that something has been held. If you want abilities, typically that's when you press the button. And if you want something that feels like you were holding something you want to activate when you let go, that's when you want to handle it with a release. So in SFML, there's kind of 2 ways that you get those events. We're finally going to use this while loop here in the middle that you guys have been seeing, which is our event handler. So there are 2 things you can use in SFML to handle keyboards. One is you can use this while loop here to put logic in here, and I'm going to show you how, to handle keyboard events. Another way you can do this is you can ask SFML if a keyboard key is down currently or not. So those 2 things are very different. This section that I've highlighted will tell you when the player has pushed or released a key. Those 2 things. So if you want to know exactly when something goes down or exactly when something comes up, you can do that. And this thing will tell you that moment that the physical key is pressed. If you want to know if a keyboard is currently held or not, though, you typically want to do that outside of this loop. You typically, here, where I've highlighted, is where you would put something like asking SFML if a keyboard key is currently pressed. So let me show you what I mean. There's 2. I'm going to start off with telling whether a keyboard is pressed or not. SFML has a very straightforward way to ask if a keyboard is pressed. So I'm going to start off with the spacebar because I think that's kind of the easiest. The first thing you want to do is everything revolving around inputs revolves around if statements typically. Like you need to know if a specific keyboard key is pressed by using if statement. Also, there's a ton of noise that comes in. Like you're pressing keyboards and you're moving the mouse, and there's a lot of things happening in SFML that are revolving around input. Like every time you move the mouse, SFML will actually tell you every single time that a mouse is moved, even a little bit. And as you're continuing to move the mouse, it'll continue to tell you, which is why almost everything starts with an if statement. So in the lab, I have some links to documentation, which I'll go over in a little bit. But this is the way of asking SFML if a keyboard is pressed. So in SF, there is something called a keyboard. In the SF namespace, there is also a keyboard object. And on the keyboard object, this is kind of like in the keyboard namespace, you can also ask, hey, is there a key press or not? So this right here is a function that takes one argument. And the argument that it takes is what key do you want to know is pressed or not? And the key that is pressed or not is another object in the SF namespace. So this is a perfect example of something that has multiple namespaces. So if you want to get to a key, you go to SF, keyboard, and then one more namespace. And in this case, I'm just going to use space. So space is the key that I care about. And this right here is an enumeration that lives in the keyboard namespace that lives in the SF namespace. So remember, this right here, this if statement, is inside my loop, inside my big loop that's on the, this is inside my main. right here. And I'm just going to do cout. Oh, let me do it. I'm just going to print out to the screen when spacebar is pressed. Okay. So this line right here will only be true if I'm currently holding down the spacebar, which means I'm currently like wall climbing or something in Overwatch, right? And this output here will show up on the left. So watch the text on the left here. Every time I hit space, this thing basically tells me that space is pressed. And I don't even have to hold it down for very long. Like if I just tap it for a second, watch, I'm going to try to tap it for as short as I can. And that's how many times that it went through that loop. So even though I literally just tapped the key, because my game is running at 600 frames per second, that means that this is however many frames that it detected I was pressing the spacebar down for. All right? So it's super fast. So this is really useful if you want to know if something is pressed. This is exactly the thing that you want to use if you want to be able to move a character left, right, up, and down. All right? Okay, questions? So this right here is inside my loop, which means that now I can tell if a key is currently being pressed or not. This is used for determining if you want to move up, down, left, right. There's a second piece, though. Remember how I talked about there's 3 different ways to detect keyboard input. One is currently if you have the keyboard pressed or not, if you're holding it down. There's 2 more. You want to know sometimes when you actually physically just press or just release the key. So in this case here, you have this while loop. So finally, we get to see what this thing's all about. So this while loop here is a smaller while loop inside this bigger while loop, right? This thing right here is calling a function called poll event, and it's feeding in an argument called event. So what this function actually does is it asks Windows, hey, has anything happened since the last time I called you? And Windows is like, yeah, I got all these things to tell you about. The player pressed a key, he moved his mouse, he resized his monitor, he's running this game, it's currently maximized, and it tells you all those things. And what ends up happening is that in this loop, it goes through each of those things that happens, and it fills out this object with what data it is. So in the case here, like if you want to click and close the window, that is an event that Windows tells SFML about. And Windows will tell you, hey, I got this event, and the player wants to close the game, which means this thing gets called. If I delete this guy, I can no longer close my window with the X. I think I showed you guys. You can no longer close your window by clicking the X button. Oops, not that. That's the wrong button. You can no longer close this window by clicking the X button. Right? It doesn't let you anymore because I deleted that code. So this is also where you get events about keyboard. So I'm going to show you inside Lab 1. There's going to be a link to events, window events.php. And this is basically going to explain all the different events that you can use to hook in your game, which includes key pressed and key release. So you can see this if statement here says if event.type is equal to this. This is an enumeration here in the event namespace under SF. We can make another if statement if event.type is equal to SF event : and then you get this nice little autocomplete dialog with all the different events that you care about. In this case, I want to know when I pressed a key. And the other thing is that I'm just going to do a cout pressed a key. I'm not going to care what I pressed quite yet. And for now, I'm going to comment out this guy here. Well, actually, I don't need to comment him out. I'm just going to leave him in there. So all I'm doing is if the event type is key pressed, print out that I pressed a key. All right. So here's my console, and here's my game. I'm going to press one key at a time. You guys can see that while I'm typing, it's putting one line in for every time that I type, which is nice. Like it actually does that. So how do I tell, though, what key I pressed? Because thankfully, this event not only includes that you pressed a key, but also that which specific key that you pressed. So if you want to know exactly what key you pressed, it includes that also as another value. So here, I'm going to say pressed. I'm going to be specific about what you pressed. And under the event object, there's another variable called key. And key is an object, it's a structure that has 5 variables inside of it. It has whether you're holding down Alt currently, whether you're holding down Control, whether you're holding down Shift, whether it's a system key. But the thing that we care about here is the code. Code here is a very common term used to determine what system key you've pressed. So this is going to represent the actual key that Windows has recognized. And so if I just print that out along with the pressed text, you will see a number every time you press a key. So I'm going to put this over on the left here. So I'm going to type in the alphabet. Okay, so every time I do this, and I missed some of those. So A is going to be 0, B is going to be 1, C is 2. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 start at 27 and go to 26. So 0 is 26. You can do page delete, end, page up, page down. Those are also keys. I'm using arrow keys. These are all arrow keys right now. Control is a key. Numlock is a key. This is break, pause. All the function keys have numbers associated with them as well. And escape has numbers too. These are all unique per key on the keyboard. Yeah. Because they actually aren't given codes. Those change functionality on the keyboard itself. Like numlock changes what the little D-pad here does. So notice here, I'm pressing 4 right now on my numpad, so 71, right? I press numlock and I press 4 and changes it to 79, which is essentially left arrow. Left arrow is 71. So I'm pressing left arrow here and I'm pressing 4 here. This is me pressing 6 on the numpad. This is me pressing right on the arrow. So this is why the numpad has those arrows on it on 8, 4, 2, and 6. When you have numlock turned off, it acts as a directional arrows. So you can use this to play your game too if you need to. All right. Okay, so that's how you detect what key you have pressed, but you can use that to put conditions. If I want to make it so that I know when I've pressed the letter Q, you can set up yet another if statement inside here. If the key code is equal to Q, and there's one of these, this list right here includes every single possible keyboard key that you could press. Okay, it's not actually that many, but it includes all the way up to like F15. If I want to know when Q is pressed, you can set up your if statement to look at this key code and compare it to keyboard Q. Just like how we did down here for detecting if we press the space bar. All right. So this is me pressing Q. Okay, this is me pressing L and any other key except for space. I'm pressing Q, and now it knows that Q has been pressed. And now you can do things like, oh, when Q is pressed, you can say ultimate activated or something like that, right? To use Overwatch terms. Or if you press W, you want to say like moving forward. So if I press Q now, ultimate's activated, W is moving forward. Notice that I'm holding down W, and it's repeating that. Like if I press Q here and I press and hold W, look how much of a delay there is between it actually detecting that I pressed the key and held it. That delay is the Windows key repeat delay. You guys probably are familiar with it, right? If you have Notepad and I press W here, that's how long it takes to repeat that. And this right here is not, it may look like this is what you want to use for using how to move forward, but it's actually not. This thing not only has a delay between you pressing a key and it repeating, but it also has a repeat interval, which means it doesn't repeat as fast as possible. This thing actually only repeats as fast as you tell it to. There's like this repeat delay here. You can shorten this, but you can take this repeat rate and move it way down slow. So this right here means that depending on what keyboard they've typed in, right, this is the Windows version of repeat, which means it also affects this. So when I press W here, moving forward is moving very slowly. So this is why it's very important to know that the difference between the event-driven keyboard events and input events that are handled outside of the loop. This is you polling, this is called polling, where you ask SFML whether a key is pressed or not. And this right here will happen as fast as you possibly can. While these events only happen as long as Windows is telling you about them. All right? Which is why repeat delay here matters a lot. That's not how fast you want your character to move in a game, right? This would be very bad. All right, so I want to give you guys lab number 1 to do. So lab number 1 is basically, hey, I want to know when up, down, left, right are pressed. Here's an example of some code that's used to detect that the escape key was pressed. The second one is I want to print out when up, down, left, right is pressed without using events. This is you asking SFML if a key is pressed or not. Then I want you to write code so that when escape is pressed, the window closes, so you can hit escape to close your game. Then I want you to draw a white square. And then finally, when you are holding down up, down, left, and right, I want you to move the rectangle up, down, left, and right accordingly. I give you some examples. So that there's like a link here if you figure out how to move an object. But the idea is that once you've done that, you'll be able to just take this rectangle and move it as long as the key is pressed. And then the last number is the space bar. When you press space bar, I want you to hide and unhide the rectangle. And this right here seems like it'd be easy, but it actually is a little tricky. So I'm going to put this up on Zool right here so you guys can grab it. And then this is, I kind of want you guys to work on this lab, then we'll do mouse inputs afterwards. Where is this? All right, so go to SDVA 203, grab that week 1 lab, and do all 6 questions on there. And when you guys are done, we'll go over a mouse input.